Okay, for question 1, you were asked to complete the square for these expressions. So remembering how we complete the square, if that's a 2x, in our brackets we're going to put half of that. So it's an x plus 1 squared. And then we think, if I were to multiply that out, the last number there would be 1, or 1 times 1. And this is a nice easy one to do in your head, because you can say, well, I want to get minus 3. If that will give me a value of 1, I need to take away 4. Second one, again, complete the square. 5, we want to half of that goes in the brackets, and it's always best to put that as a fraction, squared. Now this one's a bit more complicated, so let's say when I square that bracket, multiply it out, I'm going to get an answer at the end of 25 over 4, 5 over 2 times 5 over 2. So let's get rid of that 25 over 4, so we've got to 0, and then I want to get to 2, so I'll add on 2. So I'm going to have x plus 5 over 2 squared minus 25 over 4. 2 is the same as 8 over 4. So minus 25 plus 8 is minus 17 over 4. So question 2 is on solving equations. So to solve a quadratic equation, one way of doing it is factorising. So hopefully, if you check, you can see that this one factorises into x plus 2 and x plus 1. And then to solve it, we say, well, if that's giving us an answer of 0, then either the x plus 2 must be 0, or the x plus 1 must be 0. If x plus 2 is 0, x must be minus 2. And if x add 1 is 0, x has to be minus 1. So that's that one solved. For part B, if you look at it, hopefully you can see that we can't factorise this. There's no two numbers that multiplies give minus 3 and adds give minus 4. So if that's the case, we've got two options. We can either use the formula or we can complete the square. Now, looking at this, I've spotted that this is a nice even number, so completing the square will be nice and simple. So let's do that. So it'll be x minus 2 half 4 and squared. And if I multiply that out, minus 2 squared, the last digit when I multiply that bracket would be a 4. So how could I get to minus 3? I'd have to take away 7. So I've got x minus 2 all squared minus 7 equals 0. And then I can just solve it from there by saying I'll add 7 to each side. I'll take the square root of each side, remembering the plus minus, and then I'll add 2 to each side. So the answer to that one is x equals 2 plus or minus the square root of 7. Okay, so sketching graphs of these equations then. So first of all, I know that this first equation is going to be a U-shaped curve. It's got a positive x squared. But then I need to know where it crosses the x-axis. So I can do that by factorising. And I can see that that's going to factorise into an x plus 4 and an x plus 1. So I can see that that crosses the axes at, when this bracket 0, x would be minus 4, and when this bracket 0, x would be minus 1. So I can see that that crosses the x-axis at minus 4 and minus 1. And that's 1, and that's minus 4. And if I want to see here where it crosses the y-axis, I say, well, it crosses the y-axis when x is 0. So look at it in either of these equations, substitute in that x is 0, and here you would get 4 times 1, and here you'll just get 0 plus 0 plus 4. So that crosses the axes at 4. We do b in the same way. We factorise that, so it's going to be a 2x and an x, and I can see that that's going to be a 1 and a 3. It's going to be plus 3 and minus 2 when we multiply out. So it's 2x plus 3, x minus 1. So this graph is going to cross at, if we make this bracket equal to 0, 2x plus 3 equals 0, then 2x equals minus 3, x equals minus 3 over 2, and that bracket, if x minus 1 is 0, x is 1. So that graph is going to cross at minus 1.5, or minus 3 over 2, and 1. That's 1, again our x and y, and that's minus 3 over 2. And in this case, where it crosses the y-axis, if we put a 0 back in here, we should get that that is minus 3. Okay, for question 4 then, what you need to spot that this form is a completed square form. So really all they were asking you to do here is to complete the square. So if we start with the 3x squared plus 12x plus 5. To complete the square I need to have a single x squared at the front. So I need to take out a factor of 3 to leave that with a single x squared. So if I take out a factor of 3 from that first bit, I'm going to get that equation. 3 brackets x plus 4, x squared plus 4x plus 5. Then complete the square. So this bit, if I complete the square, I would get x plus 2 squared. Now this is where I have to be careful. If I multiply this out, the last digit is going to be 2 squared is 4. But remember then I've also times by 3. So when I multiply this out, I'd get a 12 at the end, plus 12. And I want a plus 5. So I'm going to need to minus 7. And all we do then is compare it up to the top. Well, p is a number before the bracket, so in this case p is 3. Q is the number in the bracket with x, so in this case q is 2. And the r is the bit added at the end, so in this case r is minus 7. Then for part B, it says solve the equation. Now, solve the equation we can either factorise, complete the square, or use the quadratic formula. This, hopefully you'll spot, it doesn't factorise. The clue is that we've already completed the square above, so let's use this to solve it. So really, this is the equation that I'm going to solve. So I can add 7 to each side, then divide each side by 3, then take the square root of each side, and then minus 2 from each side. So the answer to that one is minus 2 plus or minus root 7 over 3. Okay, question 5 is on solving these quadratic inequalities. The most important thing here is that we do a quick sketch of the graph. So in A, let's factorise this first to see what the graph would look like. Two numbers that multiply to give minus 10 and add to give minus 3. It's going to be x minus 5 and x plus 2. So this graph is going to cross the axes at positive 5 and negative 2. So this graph, and it can be a very, very rough graph, is going to cross there at 5 and there at minus 2. And I'm asked to say, where is this graph bigger than 0? So bigger than 0 means it's going to be above the x-axis. So above the x-axis is this bit and this bit. And the inequalities for those, this inequality is that x is less than minus 2. And the inequality from this bit up is that x is bigger than 5. So that's my answer. X less than 2 and x bigger than 5. Part B, same again. This is a difference of 2 squares, so that's going to factorise into x plus 3, x minus 3, less than 0. So this is going to cross the axes at minus 3 and plus 3. So the graph is going to cross at minus 3 and plus 3. And I want to know, where is that graph less than 0? So where is it below the axes? Well, that's this bit in here. And that's where x is in between minus 3 and positive 3. So question 6 was find the roots of this equation. So let's start by multiplying out all these brackets so we can do some simplifying. So that's going to be 2 brackets. So if we multiply this out, I'm going to get x squared. I'm going to get minus 4x plus 1x, so that's minus 3x. And 1 times minus 4 is minus 4. Take away x minus 2 squared means x minus 2 times x minus 2, so that's x squared minus 4x plus 4. And note I've left it in brackets because I'm going to subtract these two terms at the end. So the first one, if I times everything by 2, becomes 2x squared minus 6x minus 8 minus x squared minus 4x plus 4. And then let's do our subtracting. So 2x squared, take away 1x squared is x squared. Minus 6x minus minus 4x, well that's minus 6x, that'll become plus 4x is minus 2x. And minus 8, take away this positive 4, will be minus 12. And I'm not even going to attempt to factorise, because it says at the top, leave your answer as surds. So again, I could use the quadratic formula, but I'm going to complete the square, because I think it'll be a bit quicker. So if I complete the square, I'm going to get x plus, or sorry, minus, it'll be Half of that is 1 squared, so x minus 1 squared. The last digit of that's going to be 1, but I want to get to minus 12. I'm going to take 13. And then I'll just solve it. So I'll add 13 to both sides. I'll take the square root of both sides, remembering my plus minus. And then I'll add on the 1 to both sides.